Welcome back. Today we are going to discuss about data warehouse and data mining. Data warehousing and data mining are two essential processes in the modern data management and analytics that support organizations in making informed and data driven decisions. Data warehousing is a process of collecting, storing, and managing large volumes of data from various sources in a centralized repository known as a data warehouse. So, data warehouse is a repository, centralized repository of databases. Data mining, on the other hand, is a process of analyzing large data sets to identify patterns, correlations, and trends that may not be immediately apparent. So, today's agenda is we will be discussing about what is data warehouse, components of data warehouse, architecture of data warehouse, applications of data warehouse in libraries, data mining in libraries, process of data mining, models of data mining, and we will be having the conclusion part. This is today's agenda. When you were discussing about the introduction, as we discussed, in the current era of data proliferation, organizations and scientists are amazing vast quantities of information from diverse origins. So, yet the mere act of data collection is insufficient. The real challenge lies in effectively storing, administering, and extracting meaningful insights from this information. So, this is where the concepts of data warehousing and data mining become crucial. Data warehousing forms the backbone by offering a consolidated repository for extensive datasets. Once this data is securely stored, the subsequent step involves extracting valuable insights, which is where data mining comes into play. Data warehouse, if you're discussing in detail about the data warehouse serve as a unified storage system for vast amounts of structured and semi-structured information gathered from various diverse origins. Its primary purpose is to facilitate data examination, generate report, and support business intelligence endeavors. Experts have characterized it as a repository that consolidates information from multiple sources into a cohesive data store, enabling data analysts, data mining, artificial intelligence, and machine learning. As time progressed, data warehouses have incorporated cloud based solutions and sophisticated analytical capabilities. If you check, we can find that the data warehousing concept was originated in the during the year 1980s to tackle the challenge of performing optimized analytics on extensive data sets. The term data warehousing was coined by Bill Inmon in 1990s, who is often referred to as the father of data warehouse. In a data warehouse, various components work together to enable the storage management and the retrieval of large data sets from uh, various databases for analysis and decision making. Each component has a specific role in ensuring that data is efficiently processed and ready for users to use. So, we can have different components like a central database. What is a central database? Central database is the core of the data warehouse designed to store integrated data from multiple sources. It acts as a consolidated repository where data from transactional systems, operational databases, and external data sources is collected, stored in a structured format. The data from various sources will be cleaned, transformed, and integrated into common structure that supports querying and analysis. Unlike transaction databases, which handle real-time operations, data warehouses store historical data for trend analysis and long-term business insights. The ETL tools are essential for ensuring that all relevant, clean, and well-structured data enters into the data warehouse. Third component is metadata. Metadata is often described as data about data. In the context of a data warehouse, metadata plays a crucial role in managing, organizing, and retrieving data efficiently. The structured metadata describes the structure of the data warehouse, including tables, columns, data types, and relationships between different data elements. And metadata helps users and applications understand how data is being organized. Learners, next component is access tools. Access tools enable users to generate static or dynamic reports from the data warehouse. These reports can be used to summarize, compare, and present data in an understandable format. And these tools facilitate data retrieval, reporting, analysis, and visualization, enabling the users and analysts to derive insights from the stored data. It also having different tools in the access tools like a reporting tool. The reporting tool enable users to generate static or dynamic report from the data warehouse. The next is online analytical processing tool, OLAP. That tool allow for multidimensional analysis of data, providing capabilities to drill down into specific details, slice and dice data from across various dimensions. Data visualization tools. These tools present data visually using charts, graphs, dashboards, and other graphical elements. Data visualization tools present data visually using charts, graphs, dashboards, and other graphical elements. Visualization tools like Tableau, Power BI, or ClickSense help users to interpret trends, patterns, and relationships in the data more intuitively. And the fourth tool of access tool is ad hoc query tools. Ad hoc query tools allow users to perform on-the-fly queries on the data warehouse. These tools offer flexibility for advanced users who want to explore data in real time without relying on predefined reports or structure. Dear students, now we are going to discuss on architecture of data warehouse. If you consider the architecture of data warehouse, we will find it has been divided into 3 tiers. The first tier is bottom tier, second is middle tier, and third one is a top tier. The bottom tier is the foundation of the data warehouse architecture and primarily consists of a relational database system or warehouse server where the actual data is stored. The data storage in this layer integrates data from various operational databases and essential sources. As far as the middle tier concept is concerned, the middle tier is where the online analytical processing OLAP server resides. And in the case of top tier, it consists of front end tools that allow end users to interact with the data warehouse for analysis, reporting, and visualization. The next slide, which is discussing on the application of data warehouse in libraries. The use of data warehouse in libraries offers significant advantages such as creating detailed library management reports, supporting ad hoc queries, and providing historical insights for more informed decision making. Data warehouses streamline the process of generating reports, allowing for users analysis for resource utilization and decision making. Another application we can see, data warehouse enable the creation of specialized reports that might not be easily available through traditional systems. They also allow librarians to make informed decisions by analyzing both short-term data and long-term trends. Moreover, data warehouse facilitate advanced data analysis, providing valuable insight to administrators to guide for strategic decisions. Data mining encompasses a collection of advanced techniques and algorithms that enable analysts and users to tackle complex problem of efficiency. It involves the computer-aided examination of vast data sets compiled or imported to computer system. The first and foremost aim of a data mining is to uncover and highlight connections within data sets. The library management has found a powerful ally in data mining, which offers numerous applications to enhance services and operations. In the context of libraries, data mining techniques are referred to as a bibliomining. Nicholson and Santon in 2003 introduced this term to describe the integration of data warehousing, data mining, and bibliometric in library settings. The technology proves invaluable in evaluating collection development by analyzing resource usage patterns and ensuring the library's holdings align with the user's changing needs. Data mining also provides insight into a pattern behavior, revealing low user interact with both physical and digital resources. What are the different processes of data mining? A conventional data mining process is an interactive series of steps that begins with combining raw data from various data sources and formats. This raw data then cleaned to remove the noise, duplicates, and inconsistent data. The clean data are then translated into formats that other data mining tools can understand, and filtration and aggregation procedures are used to retrieve summarized data. In reality, interesting information is derived from the altered data. This data is evaluated to determine the most interesting trends. Finally, the knowledge is visualized to the users. So these are the different process. Now we are going to discuss the models of data mining process. There are three major data mining models. The CRISP-DM, the Cross Industry Standard Process for Data Mining model, is the industry's most widely acknowledged standard because of its versatility and structured approach. Another model, SEMMA, Sample, Explore, Modify, Model, Assess, is a more technical, whereas KDD, Knowledge Discovery in Databases, focus on the overall process of knowledge discovery. Depending on the unique data mining project, organizations may use one of these models or hybrid methods. Dear learners, now we can discuss these three models in detail. The CRISP-DM, or the Cross Industry Standard Process for Data Mining, is the most frequently utilized model in the industry, designed to be applicable across diverse sectors. It delineates a 6-phase process. One is the business understanding. In the business understanding, is defining the project objectives and requirements from a business perspective. And the second stage is data understanding. In the data understanding, collecting data and the gaining insights into its structure and the quality. In the data preparation, the system will clean and transform the data into a suitable for analysis. Then the fourth stage is the modeling, selecting and applying appropriate data mining algorithms to the prepared data. Then we will go for the evaluation. Evaluation means is assessing the model's performance to ensure it meets the business objectives. And the last step is deployment, where the system will implement the model into the real world environment for decision making or action. This is something about the CRISP model. The next is the SEMMA, Sample, Explore, Modify, Model, Assess. The SEMMA, it was developed by SAS Institute, and this model focuses more on the technical aspects involved in data mining and analysis. It encompasses sample, explore, modify, model, and assess. Sample means here we are selecting a representative data sets for analysis, then going to explore, analyzing the data to uncover patterns and relationships. So here we are going to explore, that means analyzing the data to uncover the pattern and the relationships using data visualization or clustering associations. In the modify, where the system will transforming the data into the optimal format for modeling, that using the variable selection creation and data transformation, the data will be transforming into optimal format of modeling. And the fourth stage is very important stage. There we are applying statistical or machine learning models to the data using any models, neural network, tree-based models, logistic models, or other statistical models. We can have the process in this statistical process using statistical technique and machine learning models. Then last stage is assessment, assess. Here the system going to evaluate the model's accuracy and utility for future predictions or actions. So this is something about the SEMMA model. The next is KDD, the knowledge discovery in databases is a process having more research-oriented framework that emphasizes the discovery of useful knowledge from data. It comprises 5 stages. The KDD process comprises 5 stages. The first one is the selection, where we identify relevant data sources and selecting the data for analysis. And the second stage will be the pre-processing, where we cleaning and formatting the data to eliminate noise and inconsistencies. And the third process is transformation, where we converting data into forms suitable for mining, such as aggregation or normalization. And the fourth stage, we will be having the data mining for the transformed data. Data mining, here we are applying the algorithms to identify the patterns and the models in the data. The last stage is interpretation and evaluation. Here we try to interpret the data and evaluating the result to extract meaningful knowledge for the decision making process. So, this is the whole process of knowledge discovery in databases. Learners, now we are going to conclude this session with this words. Data warehousing and data mining work together to help organizations to make smart decisions based on data. And this data warehousing and data mining play very important roles in managing and analyzing large volumes of data across various disciplines. The application of data mining enhances decision making, enabling the analysis of collection development, user behavior, staff performance, and service optimization. And data warehousing gathers and stores large amounts of data from different sources in one place and making it organized and easy to access. In other hand, data mining analyzes this stored data using advanced technique to find patterns, trends, and useful insights about the data. By combining the vigorous storage and retrieval capabilities of data warehouses with the analytical power of data mining, libraries can improve operational efficiency, enhance user experience, and make data-driven decisions that positively impact their services and resources. Dear learners, I stop here. I thank all the learners for your active involvement, and we will meet with another topic in the next class. Till then, goodbye.